Okay, stack attack. Alright, final one for today. Holy crap. Alright, 3-6. 3 point. Chapter 3, Problem 6. Animal shelter. That's the LJ. Alright, let's just copy everything we had here. Although I think a lot of this is actually not going to. Well. Okay. Alright, so. Animal shelter. An animal shelter, which holds only dogs and cats, operates on a strictly first in, first out basis. Okay. People must adopt either the oldest based on arrival time of all animals at the shelter, or they can select whether they would prefer a dog or a cat, and they will save the oldest animals of that type. The oldest animal of that type. They cannot select which specific animal they would like. Create the data structure to maintain the system and implement operations such as enqueue, enqueue, DQ any, DQ dog, and DQ cat. You can use the built-in linked list data structure. Well, that seems like cheating. All right. So obviously, we're going to use a queue, and oddly enough, this is the first queue question we've had on this entire chapter, other than the build a queue out of 2 stacks question. But queues are largely similar, right? Instead of having a pop, you technically have a remove. Although they called it a DQ there. Actually, okay, so let's give them their names. All right. So I don't think we need the is empty at all, but guess we don't need. Is a DQ supposed to be something? I guess I'm gonna guess that I'm not clear whether a DQ is supposed to simply remove the dog or the cat or the any, or whether a DQ is supposed to return the dog or the cat or the any, or whether the DQ is supposed to do both of those things in one operations. I kind of feel like it's saying it's supposed to do both of those things in one operation. All right, so we don't have a queue, right? Let's get ourselves a queue. I did press the record button. Yes, good. Okay. Oops. And all right, so let's build ourselves a little queue. What does a queue got? A queue has a did anyone actually use is empty? I guess yeah, actually they did. So let's bring that back. Okay. So what is the fundamental data structure here going to be? Shelter, right? And it's going to be a map that contains dogs and it contains cats, and each of those contains okay, yeah, it contains dogs and it contains cats. What else does it contain? Or maybe it just contains all, and we just have a. No, I feel like it should contain dogs and cats separately, but they're both going to contain queues, right? Which does not exist yet, but. And so one thing we need to define is a queue. So let's define a queue. A queue, let's just start off with the empty queue, is going to be a map that contains values, which contains another map, contains min key, right, which is 0, and contains max key, which is 0. Or maybe the min key is actually -1. Or nil. And max key is 0. Or no, I think maybe there is no max key actually. There's just a min key. And that starts off as nil. Let's actually start off as -1. I think that might make some sense. All right. So we got a queue, which is just going to be a map of keys to values and a min key of -1. That's a queue data structure. And so let's go through the different ways we can do this. How can we ask if something is empty? Well, that's pretty simple. You take our queue, right? And you say queue values empty, right? And if that's the case, then yes, it's empty. How can we ask if we can peek at the queue? So we have to ask if it's empty, right? If it's empty, you can't peek. But if it's not empty, then I think you can just take the peek is the latest thing added to the queue, right? So I think it's the get from the queue the key with get from the queue the key with values of, that is the count of values, right? So however many items are in the actual queue, right? Now that would work if we weren't dequeuing things on the other end. So what we need to do is kind of like subtract the min key. Maybe. I mean, what would it mean if I pushed at this moment, or if I popped at this moment? Well, I think that would give us the peak, right? You take the queue, which is, oh, well, actually, you take the values out of the queue. I don't like doing this in general, but let's just take values and then key on. Okay. All right. Okay. So get from values, right? Get from values the count of values minus the min key. I know that'll work for the very first one. I'm not sure about the rest of them. It'll work as long as the min key is 0 too, right? If you have no items in the min key, or if the values is empty, then this should have exploded. But if it's non-empty, if you have one item, then if you have one item in there, right, then there should be one key in there that says 0. That's a element 0. So you should be 1 minus 0 minus 1 is 0. And you're going to get the value at 0, and that's your peak. I think that makes sense. What about removing? Well, theoretically, I think you just need to calculate what you want to remove. I think we're going to do something pretty similar. Calculate what you want to remove. So we got to first figure out, I think, this same logic right here. I guess we should call that K probably. So we're going to count the values and the min key and 1, all that stuff, right? And you know what? We should move this into another function. Let's call this head. And it's going to take a q. But q is actually going to do this. I prefer to do things this way in general. Q, right? And we're going to do a little calculation to figure out what the current head is. Okay. So assuming that calculation is correct, we can just say get values get from values. I guess we do need values, so get from the values of q the head key of q. That's for peek. For remove, we just need to get the head key of q. I think we're fine with this now. Let's think about this. Now that we know what the head key is, actually, we don't really care what the head key is that much, do we? For remove, because all we're going to do is drop or increase the min key. We're going to increase, the goal here is to increase the min key. I guess there's this. No, it doesn't really matter, honestly. Okay. So I really don't think we need this at all, actually, in this one. But we do need the min key, which somebody's missing an as up here. Okay. We do need the min key, which is going to be, let's just switch sides. 2, 3, getting crick at the neck. All right, we do need the min key, which is, we're just going to increment, I believe. Well, I guess we're also going to ideally drop out the, okay, so we have Q. I'm saying update in Q the values. I'm going to say disassociate the min key. I hate this. Okay, that takes it out of values, right? That's always an operation that can be done. But then what about incrementing the in key? Update in values, not in values, but in min key, increment. That's it, right? So Q, you're going to update in values by the values map by disassociating the min key, and then you're going to update the min key. You effectively just removed the min key from your Q. I think that makes sense, but I guess that's fine. I'm still, okay, a little bit wonky about, it starts at 0, so that doesn't seem right. It's okay. I'm not sure what this should start at. But anyway, let's do my push. And how did this end up in here? Oh. Okay, my push is going to be can you always push onto Q? Yes, you can. You need to basically do the inverse of what you did here, I believe. It's actually kind of interesting how much of an inverse it really is. So you need the min key, right? And you also need really just that, honestly. And from the Q, you're going to onto values, you're going to associate the min key incremented, the increment of the min key, right? Okay, so this does that in this map, and this you're just saying assoc into min key, the new min key. No, you're not. No, you're not. You're not doing any of these things. I'm getting shit confused. This should not affect the min key. You don't even need the min key. All you need to do is set the key to be the count of VS, or the count of values actually. I don't think there's a clean way to do this in a single update. Alright, well, if there's not, then there's not. That's fine. Alright. If there's not, then there's not. And then values min key as Q. Okay, so we definitely have everything here. Let's just talk about what we can return. Let's just return a map with values and a map with min key. The min key should be entirely unchanged, right? Yeah, so I think really we just need to associate into Q the new values, which is going to be, we don't care about min key at all in this. What we do care about is the count of values. Oh man, Steven. What we do care about is the count of values, right? Because that's what we're going to associate the values, the count of values, and V, right? That's it. I mean, boy, why can I not? Yeah, you can. Okay, so update into Q, the values map. So the values map is the context now. Now assoc into that context the count of values, which you kind of pulled up from up here, and the V. I'll just put a little helper here that says like it's not a great name, but what this does is it takes a map and it takes a value. And what it's going to do is just this right here, really. Associate into a map the count of the map by its value. Oof, neck. Okay. That means we could reduce this one down to just being update Q values, add by key value, right? And okay, I think that makes sense. All right. Come on, man. Okay, so that's a push. All right, that's a push. It's actually pretty clean. So Q is values. I feel this push is, I think, pretty good, you know? For whatever map, it's just going to add another item into the map. Oh, crap. Oh, crap. We do need to know all of that. Stupid. Oh, son of a gun. We did need the min count because we need to know what the offset is. Okay. Alright. Keys. Min count and values. On Q. Alright. I'm going to update. I'm not going to do any of that. I'd like to just use something like this, but it's just too complicated. Yeah, actually, oh, that's what our head key is for, right? Oh, maybe this is what our head key is for, right? Let's call it the next key. On Q, right? So that's the next key that we can use, right? That's the next key that we can use. Count values minus the min key, which I'm still wavy on, -1. So if there's 0 values, I don't quite see why we're subtracting 1. Yeah. Okay, yeah. You're taking the current number of items and values, and then you're going to subtract the min keys from it. At the very beginning, when the app started, the min keys is 0, and the collection is 0. So you're doing 0 minus 0 is going to give 0. That's the next key that you should be using. So when you're pushing, you're saying, the next key I'm going to use is 0 for the very first queue. And I don't think we need any of this now, but I do think we might be able to do this. Change this to assoc in. There is no assoc in, is that right, or did I make that up? Nope, it's there. Okay. So assoc into Q, enter values under the index of that position, that value. Now we're out of this guy's business. Now push is comparatively simple. You get the next key that you're going to be using, and you just assoc into Q, the values, the next key, and V. Okay. And then, alright, so I feel good about this. This is a pretty clear empty, and then the collection is empty. I feel pretty good about I feel somewhat good about this. I feel pretty good about, well, let's look at it again. My peak. So what peak should be doing is just grabbing the next key, right? So you're grabbing the Q, grabbing the next key from Q, and decrementing it 1, right? And that should be the thing that you can currently see, right? Because the next key is the next key, but the previous key is the head. We're talking about, oh wait, the peak is the reverse of that. Peak in the Q context is the, now peak is the head. Well, but peak is what you're going to remove, right? So peak is I think peak is the min key, actually. Right? Okay, and here's the issue, right? what's the issue? Here's the issue. Makes sense to me. My peak should be looking at the min key and grabbing from values the value that is the min key, right? But this isn't strictly true. Min key at this moment in time is not really zero. Right? I mean, you don't grab the key at position 0 when you peak. Now this will short circuit anyway because this will fail, right? But okay, so putting -1 in there again. Holy crap! We've gone back and forth like 10 times here. So is empty. Does empty care about the min key? No, it doesn't. So that couldn't affect it. Is next key care about the min key? It does. Which now I feel like, okay, I'm back to doing this again, you know? Because in order to get the first one, to put the first thing in there, you know, you got to do the count values, which is 0, minus the min key, which is -1, plus 1, which is 0. And that's the first one you're going to put in there. Fudge. Okay, my peak. I'm going to get the min key. That makes sense at least, because if you pass this point, we have something in here which you should just get the min key. That's your peak. My remove, the same thing. You should definitely be using I feel like you should be using next key as well at some level. No, you shouldn't, because you're removing off the bottom. So you should really be looking at min key. And yeah, I think that makes sense. You're just going to remove the item you're going to remove from values the thing that is the current min key, and then you're going to increment your min key by 1. I feel like that makes sense. Now what about push? You're going to grab the next key. Is this the only guy who's using next key? That seems weird. Why does only one person need this? I can get that is empty doesn't need it. I can get that my peak, and I guess they don't need the next key because they aren't concerned about stuff being added. They're only concerned about stuff being taken off the tail, you know? Okay, so this is here. And we're pushing. We're just give me the next key. Okay, Q. And then I associate into Q the values at K and give it a V. Now, I guess that's all 4 operations, right? Does it make sense? And it does make sense. I mean, who else using min key? A lot of people, unfortunately. Pretty much everybody, actually, in some way. Even push needs the min key because he needs to know how much to offset by. But let's say you have 0 elements. Then it's count of 0 minus 1. Oh, that's minus -1 actually, which means plus 1. Oh yeah, minus -1, which means plus 1, and then we subtract 1 from that to get back to 0. So your min key of -1 became next key of 0. That makes sense. Now when you have a 0, you can try to peak it at 0, right? By just peaking at min key. That makes sense. You can remove the 0th element by grabbing the whole thing, grabbing the min key, which is at this point now 0, disassociating the 0 key from values, and incrementing the min key into something that doesn't exist. That doesn't make sense. Interesting. Well, but does it matter that it doesn't exist? Does it matter that it's anything, actually, as long as the math on it is correct? Yeah, so now your min key is technically 1 now, right? But who cares? Well, I care because now the next key is going to be 2, right? It's going to be the count, which is 0, minus 1, minus 1. Well, that just seems totally wrong, doesn't it? No, I need a monotonically incrementing thing. Like, no matter what, it just needs to increment. So something about this... Maybe it's just the fact that I'm holding 2 things. Maybe this is just stupid, and I should just... Maybe it'd be much simpler if I just min key and max key the whole thing, right? Let's walk down that path a little bit. So we're checking empty by just saying is empty, right? We're checking my peak by saying you're not empty, and I need to know your min key and the values in order to get your peak, right? I'm checking your remove. I need to know your min key. It feels like I need to know your, well, but I'm doing the update, so that's fine. But Q, I'm getting your, I'm going to disassociate min key from your values, and I can increment. I can increment n key, but I still run into the issue where max key and min key could be the same thing. They could both be 0, and now it's possible that I'm incrementing your min key beyond your max key. Now that can really only happen I'm incrementing your min key beyond your max key. Now that can really only happen Yeah, I just don't know about this max key thing. I mean, it feels like with just the min key and I'm gonna back up the max key thing. I don't like it. Okay. But I don't think this matters. I think this is irrelevant. We can start at 1,000. It doesn't really matter what the min key is, as long as it's incrementing in a certain way. Back up again. Is empty. It's always going to be good. It's a good one. Next key. We're not sure about that. My peak. My peak. Yeah, and this is a stupid thing. Why am I getting the next key? I should get the max key. That's what I really want to know. I can figure out the next key just based on the max key, but it should be a computed thing, not a thing that I have to keep track of. But anyway, my peak, I'm getting a min key and a value, and that seems pretty logical to me. My remove, I'm removing the min key and I'm incrementing the min key. That kind of makes sense. Okay, so I feel weird about incrementing into a min key that doesn't exist in your collection, but you can't peek or remove anything that's empty anyway, so it doesn't matter, you know? You can only push onto an empty. An empty on an empty, right? So it doesn't matter that the logic doesn't have to stand up to being an empty values. It's fine. So and it's fine that this is that we were at 0 and now we've incremented the min key to 1, right? We are at 0 and I removed element 0, right? Or really, I just called my remove, right? Which removed the element at element 0. There's now an empty values, right? And min key has moved on to 1, right? That's weirdish, right? Or it's not weird. But it doesn't matter, right? It just means that min key now starts at 1. Okay. Now this guy really should be max key. So I'm just going to say max key, Q, values, and min key. No, it's not. Well, yeah, it is the max key, the maximum currently existent key. But next key kind of it does make more sense at some level, because what I need from it is I just need to know what I should put the next key value as, and you can always put it as the current size of the collection. But am I creating? I'm creating empty slots then if I do that, right? There's something I'm missing here. I know. I'm creating holes because I might have removed something where the min key has gone to 1, despite the fact that there's... So what happens if the min key has gone to 1, then and the collection is empty, or the values is empty, and the min key has gone to 1? What happens when I put a new guy in? Well, pretty much the same thing as what would happen from the initial state, right? Which is to say, it'll put in... I think it'll put in 2. Actually, it would put in 0 again. Why can't this work? This can't work because count can in constant time figure out its size, but what count can't do is I feel like somehow I should just be able to use count and min key to... But the problem is count decrements while still incrementing. Count can get smaller as a size while still incrementing min key. That doesn't make sense. This is the guy that doesn't make sense. If you disassociate something from min key, if it's within a range, now the min key should go... the min key should definitely only be going up, but it doesn't make sense for the min key to go up. In the general case, it makes sense for the min key to go up when you've popped an item off the values. When you've removed an item from the values map, right? And it should be the minimum key in the map is what goes up. And so the minimum key, the min key, should go up 1. But when you do this computation, the map is now in -1 of its previous size, and the min key is the min key plus 1 of its previous size, which means it's still, I think, trying to put it into the same place. What can we do? I mean, I guess the biggest... Oops, I meant here. The biggest thing we can do is stop relying on the count of values and only rely on a min key and a max key. If we do that, we gotta check things like... Well, do we? I mean, you shouldn't be able to remove anything if it's not... You shouldn't be able to remove a key that isn't in... I'll think about it for a second, but I'm good with this. I think I'm good with this too. I'm gonna back... is the issue the fact that this guy's changing in size, but this is always incrementing by 1 on removes? This guy gets smaller by 1, but this guy increased by 1, but that still means the next key is still the same value. I think that may be the issue. So that means we need 2 separately tracking things. Okay, so if we do this, I don't think there is really a max key. There's also no clarity about, should it be max key or should it be next key? Boy, this seems simple, but it's something subtly wrong about it. I can just tell. Also, I'm very tired and hungry. I need to make some. Okay. If I have these three attributes, I have a map of keys to value, right? I have a minimum key and a maximum key. The problem is, what's the fundamental problem already? This doesn't mean a whole lot, right? Should the min key and the max key start at the same value? Let's start with that. Well, yeah, but initially, neither of them exist, right? Initially. So it's a bit of a lie, right? There is really no min key and no max key right now. I mean, I feel like maybe logically, every time I push something into using my push, we should just increment the max key. Similarly, every time I push something, I disassociate something from with my remove, we should increment the min key, and we should finally also be checking. Well, I don't think we need to check anything because if it ever is the case that the min key and the max key are equal, the remove, the peak, will all assert false. So is it just as simple as just copying the logic here? Taking this whole thing out as a concept and changing this from values assoc min key v and max key increment? Is that just a much simpler data structure? Values. Okay, so let's start from the beginning. I built a queue. I want to put 1 onto the queue. What's it going to do? It's going to go to, well, first of all, I want to remove 1 from the queue. I want to remove something from the queue. It's going to blow up, right? Because the queue is not, it is not the case the queue is empty, right? I also want to peek at the queue. Well, it's going to blow up because it's just not the case the queue is empty. I ask, is the queue empty? The queue says, yes, I am empty. All right, say cool. So I guess the only thing I can do, since the other 3 methods all failed, or return false, the only thing I can really do is put something onto the queue, and I say cool. And so I go through here and I change I just take my value, I take my queue, I update values by associating to my max queue, which is currently 0, the value v. I then also increment my max key. It's a lie though. That's not your max key. Your max key is 0. So it's like almost like the max key needs to start at something less than the min key. But you can't do that because now you're putting your max key. I mean, I feel weird about it, but what about this? Oh, that sucks. Don't do that. Next max key, right, is just the increment of max key, which isn't really true. I mean, it wasn't your max key. There was nothing in your map. You have no max key. But I think maybe this works. And rather than doing this, let's just say assoc max key, next max key. Is that okay? So now your max key is -1, but you incremented it 1, so now it's 0. And so you update into your values the next max key of v. And then you assoc into your max key the next max key. So now you have max key set to, 0, min key to 0, and values containing 1 and v. Let's say I go in the direction I then pop something off. My min key is 0, my max key is 0, and my min key is 0, my max key is 0. I don't care about my max key at all here. What I do care is that I'm going to disassociate my min key. So that seemingly makes sense to me, disassociate min key of 0. And then I'm going to increment my min key to be 1, actually, which is interesting because now we have a min key of 1, a max key of 0, and an empty map again. So I feel like we're back to effectively the same starting position we were in before, right? That's interesting. What if I didn't go that way? What if I instead said, okay, so I now have a value of 1, a min key of 0, and a max key of 0, right? I'm at that stage. And I instead then push a second item, v prime, onto there. Now my max key is 0, right? So I'm going to take my next max key, which is 1, right? I'm going to update my values to be my next max key. Yeah, my next max key 1 with v. And I'm going to associate my max key to now be 1. So now my min key is still 0. My max key is now 1. And my values contains the keys 1 and 2. Or, holy crap, 0 and 1, I believe? Yeah, they contain 0 and 1. I think that's a Q at some level. I think that's a Q. We haven't started on the problem yet. Okay, so I think that's a Q. So if we have Qs, now we can have a dog's Q and a cat's Q, right? And it is a, let's make sure again, it is the oldest, yeah, so this is a Q is what we want. Last in, first out. No. First in, first out is what I'm going to say. So, all right, we want to, and what additional functions do we want for our queue? Well, glad you asked. We want a in queue. QU, I always have a huge amount of difficulty spelling this word. Is it, over here. All right, we got to in queue our shelter. We're going to, we're going to in queue our shelter. We're going to so that allows us to add new animals. Okay, yeah. We're gonna DQ any, just DQ actually, from our shelter. We're gonna DQ cats. Oops. From our shelter. And we're gonna DQ dogs from our shelter. Okay. Okay. Alrighty. Okay. So, how hard is this? We got a shelter. Should we call it the same thing? That's fine. I don't. All right. So what is InQ do? Well, I guess it needs to decide, is this a cat or a dog, right?
How does it know whether it's a cat or a dog? I guess it's a map, right, that contains kind, right?
I guess we should give the cat a name too, you know? Yeah, okay. So it's going to take a shelter and it's going to take a pet, you know? This is going to just take a shelter, a shelter, and a shelter. Okay, yeah, that makes sense. And so if you take a shelter and a pet, we just got to say if the pet kind is equal to
If the pet kind is equal to
cat, right? Let's do a con. I don't like if things where you just leave the other one as the. All right, so if actually we can do a con p equal kind of. Oh, you know what? Actually, I just think con p equal kind. No, we do need to do kind of pet, you know. And so if it's a cat, we're gonna say put into the cat queue, which basically means update in the shelter the cat's queue with a, let's throw a my push your direction, and I'm going to pass in this value. And if it's a dog, I'm going to update. Oops, did I singularize one and pluralize the other? No, I didn't. I just screwed up. All right, it's a dog's. I'm going to my push into shelter under dogs. Which actually really means we really don't need to be dispatching on this, but we can just do this. The kind of pet, right? I think that's in queue, right? Okay, all right. Now to DQ. I guess we kind of need. Well, I'm not really clear what they want here. Do they want different queues? Do they want us just linearly search the queue? What do they want? Do they want constant popping and pushing onto queue times, or do they want and so if we do a single queue, right, we can do that, which means that we do know which pet is younger, but what we don't know is or older, I guess I should say. What we don't know, I guess all of them are going to require. No, they don't all require linear scanning. They require. Gross, but I think we will need a. Oh yeah, there's no V, by the way. But what they may need is an ID, right? I guess. Which are a timestamp, I guess, right? So the shelter should hold a timestamp for. I guess does the shelter need? Yes, it does need a timestamp. Please don't try that whole experiment with the size of the container again. That was just failure. So let's just put another value in here called tick. Huh. Not ticks, but tick. All right, so 0, right? And what we're gonna do is we're going to. We don't really need anything but tick here, actually. Start well. No, let's do that so we know that we start with vectors, which are. Well, no, actually, so that we start with queues. Okay, so that's a new shelter created with 2 queues inside it for cats and dogs. Okay, and You know, I'm gonna keep working on this, but I'm gonna just pause for 2 minutes to put some rice in my cooker and all that kind of stuff. Sorry. Alrighty. Yeah. I forgot to unthaw the sausage. It's annoying. Alright. Let's see. So we got NQ, update shelter. We got DQ. This would take from whichever one has a lower tick rating. Right? And the tick rating should be... Yeah, so we just need to peek at both of them and ask which one is smaller. It's too bad we can't share some of this code. I think we can. But let's just do one at a time. Or maybe let's focus on just cats first and see. No, I think this may have more common causes. So DQ, we're going to take the shelter. Then we're going to take... Wait a minute, I have immutable data structures here. I don't give a shit about... Well, wait, that doesn't help me. Shelter, yeah. Okay, so let's just not get cluttered here. Tick cat, right? Just going to be the shelter, then the cats, then the my peak, right? Tick dog, right? Shelter, cats, my peak, tick value. Oh, you know, I forgot to actually add the tick value to the update. Let's sew this into the pet. The tick value of the tick of shelter. And then Sos or update in tick increment. So we never have the same. No two pets have the same tick, right? And their ticks increment as we add new items. And our goal is to generally be taking DQing from the guy with the lower tick value. In the general case, right? So, whew, okay. I don't know about doing a chapter a day on this stuff. It's a lot. But, okay. If tick cat is less than tick dog, and one of them has to be lower, right? Then DQ cat. On the shelter. Otherwise, DQ dogs. Holy moly. Alright, and so if we can, so obviously the DQ cats and the DQ dogs need to come before the DQ. I'm going to do it that way. But I think the logic is going to be shared for both of them. So let's just see what we see here. DQ breed, right? It's going to take a shelter and it's going to take a breed. Or a species. species? Is that it? Species? What do you say? Where's that movie? Species, man, that was a. But that's not. What is species? Yeah, okay, it's a word. Alright. Species. And we are talking about dogs here, not cats. And, alright, so we're DQing a breed, which takes a shelter and a species. And so we just need to go to shelter, and we need to grab, or I think we just need to actually update in shelter on breed, right? Species, I mean to say. And then we're just going to call my that's true actually. We need to peek. I think DQ means peek and remove. So that's what my feeling about what peek means is. So this is the actual pet, right? So we didn't really need to update this. We actually just needed to. Well, that's fine. I mean, yeah, no, that's fine. So this is the actual pet that we're going to return ultimately, right? What we're going to also do is, wait a minute, I can't do this in an immutable language because I can't modify the thing and leave it modified. Yeah, DQ doesn't make a lot of sense in an immutable language. What can I tell you? Well, I guess we could put the whole thing in we could make shelter an atom rather than making it a value, but that seems like a terrible trade-off, you know? What do we want to do here? I don't know, man. We could make shelters into atoms, right? It's going to be harder to test, harder to, reason about for a pretty small gain, honestly. And the fact that we can do something is truly a DQ, which is, so let's look up, what does DQ mean? Yeah, so I do feel that DQ means mutably take something off a queue, mutate the queue, and return the value. But, I mean, unless we want to do atoms, I don't think that's a good idea. Oh, hell. Let's do it. I mean, so a shelter is now not returning this. It's now returning an atom, actually. And, which means this whole guy... I mean, this is just, it just becomes radically more complicated if you can actually change things through time. Because who knows who else is using this at the same time. In fact, like... Okay, let's stop complaining. Does DQ cats and DQ dogs require an atom or a value? Well, I guess at least we can give this guy a little more specific name, a shelter atom. Right. And they all take shelters, and they need to return new shelters. And I'm okay with that. But it just sucks. Okay, yeah. Okay. What about InQ? Does it need... Well, no, I think it's okay to be able to just call. Yeah, we don't need a function called DQ. I mean, you can make the assumption that people are going to be able to call swap shelter atom with the function name. So we don't need to... We can assume we're... Well... Actually, the DQs are weird in that they're relying on a side effect, right? And they're getting a value out of them. DQ breed. I am not sure this is a smart place to go, honestly. In fact, I really just disagree with this, everything that I'm doing here. Although I'm a little confused about what it just deleted there. Okay, alright. Take out the atom. Okay. Alright, so... Okay, assuming I'm not going to implement... I mean, I can do something sneaky, like return the new shelter, but in the metadata it has the name of the dog that we just emitted, you know? Or we could do DQ dogs and DQ cats, or DQ breed, really. Returns two things, you know, it returns... I mean, an AQ takes a shelter and returns a shelter. So I feel like a DQ should... Okay, yeah, I think I was just going a bit silly for a while. We can deal with this. Right, what we return is new shelter, right? Which is just I'm not sure, but okay. Pet, which is just going to be pet, right? I feel like we don't really need to know that anywhere but here, actually. So pet is going to be the pet, and then the shelter is going to be the modified shelter with the pet removed. So I think we're just gonna, same thing pretty much. Update shelter species my remove, right? And they should, the thing that's peaked is should also be the thing that's removed. Yeah, that makes sense. And so yeah, you gotta pull it out basically. You gotta pull out the pet, and you gotta pull out the shelter. That's fine. And so DQ cats is just gonna call DQ breed, DQ UE breed with cats and with shelter cats. Excuse me. And DQ dogs is just going to call out DQ breed with shelter and dogs. And so these are the three functions they ask us to implement. 3 functions they ask us to, or 4 functions they ask us to implement total. A little bit of a helper function here to just avoid duplication. And yeah, I think that's it for the shelter logic. Assuming, like, if you already had a queue data structure, which I don't know if I've ever used it, but I'm 100% certain there is a queue data structure at some level in Clojure. I still don't believe you. Clojure queue data structure. Okay, so it's just not one of the 4 fundamental data structures, but it does. The Clojure persistent queue doesn't have literal reader syntax or wrapper, so you have to create them using Java call. Acts exactly how I expect them to. Since not having a literal can make this a pain, let's make our own. Oh, this guy's going to the trouble of actually making it into a. Oh, is that literally all you have to do to make a queue in Clojure? And then it basically looks like a list, which is. If you peek, you get the front. If you pop, you get everything but the front, but the head. Huh. Okay, that's why the seek is there. I was kind of curious about that. Okay. Well, so it's really not hard to make a queue in Clojure. Just basically do this. Oh wow, these people just use them using vectors. Well, interesting and fun things to read about, I'm sure, but I implemented my queue with maps. Maybe I'm silly. Okay. All right. I mean, theoretically, that's. I've written the code that I intended to write here. Oh my gosh, I'm gonna have to correct it all. Now there's all this testing I gotta write. I am running on Steams at this point. All right, so let's just t/is. Let's start with the base. All right. I mean, there's really no need to check this, but what am I even checking? I mean, what do I care? I feel like maybe we should check just that the queue implementation works the way we expect it to work first. Actually, some of that stuff there wasn't probably garbage for testing out queue even. Okay, so alright, let's maybe do 2 tests actually. Because we basically have 2 separate programs here. Okay. 0 queue. We got a queue stack. And stack 1 0 stack 1. Okay, that should work, right? And stack equal, reduce my push, do this. So I think these would all still work as queues, right? We should check this. Yep, stack 0, 0, 0. That should be true still. My peak. No, of course, none of them are stacks. All of them are queues now. So. Alright, but equal queue should take the 0 queue, 0 queue. Okay, okay, okay. What about this? Check non-empty queue functionality. So yeah, when I peak at an empty queue or at the Q1, I should get 1 item. When I pop the Q1, I should get 0 Q. That makes sense. Okay. I feel like this was the last logic for what was a stack, so everything is kind of going to be backwards. So rather than popping in, well, at least they're going to go in A order, but I think it's going to be in opposite order. It's going to be last in, first, FIFO, first in, first out. So it should, if you put in ascending from root, then you should return ascending too. If you put in descending from root, you should return descending, I feel. This should return 1. And this, let's just test this one a little bit. Let's get the first, let's see if we can get this to pass, and if so, we can, oh, that's obviously not the right one. Can I resolve symbol value line 9? Okay. All right, get values. Really? Can I see it right? Oh, wow. How is this even passing? Why is it not exploding about the let being completely messed up? I don't get that. Is that a Babashka thing? Line 21, column 9. Wait, what? Oh man, you screwed that up too. Okay, Q. 29 def test. What's up with that? Huh? That should work. That's worked in every other one. Why would def test not work here? T/def test my test. Could not resolve symbols T/def test. Well, that just seems hard to believe. Huh? Def test. What am I missing here? Huh? I feel like something's just very. You were able to process the previous one though, right? So obviously def test isn't that complicated. Oh, I see what's wrong. It's just... No, actually I think that's just kind of a bug. Could that be it? That this is just weird? Is it literally this that's messing it up? No. Def test. Could not process def test. Def test. It's right there. You can do it when it's 3.5, but you can't when it's 3.2. Else. T/def test. My test. T/def test. Q test. Oh, I gotta require it. I see. Okay. Oh, let's just do that at the top then. QQ at line 32. 0Q QQ. So I just need Q. Thank you very much. Could not resolve symbol mapop. You're right. It's called my remove in the world of Qs. My pop becomes my remove. Could not resolve symbol tick. Okay, what line was it? Line 59. Okay, good. We moved beyond, so I'm gonna just comment all this out, and let's just talk about. You need to run the test, don't you? Okay, so I failed one, so that's actually pretty good. My remove Q1. Check non-empty Q functionality for 0Q. We said it should be. Actually, yeah, those are. Actually, none of that worked. That didn't work at all. Zero Q might remove Q1, line 31. So, oh, I hate that. Come on, you can give me a better line number than that. Anyway, it happens to be this one. But, alright, so if I calling my remove on Q1, then I should get the 0Q. Kind of. Not necessarily at all. Right? That's not true anymore. What should happen, though, is it should be empty, right? It is not empty, though. If I remove one item from an item with one element in it, it should definitely be empty. But instead, what actually happens is it gets another value. How embarrassing. So it's got the keys 0 and 1 in it somehow already. I don't even know where it got the. Oh, never mind. That's a map. It's got the key 0 with the value 1 in it. It kind of. So my remove appears to have just returned the original one practically, which is surprising. I mean, that is the value of Q1. Actually, I see something very wrong, which is that our max key is less than our min key, which should never happen. Okay. Why is our max key less than our min key? My push is incrementing my max key. My remove is incrementing my min key. just try something a little different. Your peak is 1. Your remove is the empty. Let's just check. I should not return empty. Are you saying, I find that confusing. Let's just say equals false. You're saying that my peak, well, that is not a queue. Okay, so that makes sense to me. So is empty seems to work. 1 peak seems to work. Remove is not working. And I'm not clear why. It's comparatively simple. My remove Q1 there's no conditional in there at all. If I can see them, let's just see what Q1 looks like, you know. Equal nil Q1. Q1 ends up being what I think it should be. Alright, nil, so I got a max key of 0, a min key of 0, and a value at index of key 0 of 1. That seems pretty good to me. That seems like a good start. Now when I pass that value to my remove, it gets past this point, right? Because our values is non-empty. But then we get Q. We're going to go into values and disassociate the min key, which is 1, actually. Ooh, that's not right. Why is it 1 already? No, it's 0, yeah. Dissociate the min key, which is 0, right? And that should work, right? You should disassociate 0 from this values. Okay, and then we're going to increment min key by 1, which does make it 1, which is kind of weird since max key is also 0. Why does that happen? I mean, generally speaking, removing shouldn't increment max key. This is why I wanted to use the containment, but it seemed like that was too hard, too complicated. Why do I need to... I mean, maybe I am off by 1. Maybe I should be starting max key at 0 as well. How many people use max key? This guy, basically just this guy. I think the thing that's confusing is it's not really the max key. It's actually kind of the next key. There certainly shouldn't be less than the min key ever. No, it just got a lot worse. Max key. just not quite clear about what that really should be. Maybe it should put the max key in, but then it should. Then you might as well just be doing the same thing. So now max key is 1 and min key is 0. That's really not true. The max key is not 1. Maybe what we don't want to say the max key. Maybe we want to say the next key. Well, yeah, that's not going to work. We need. Wait, who else is using max key that would be an issue? How can that affect that much? It's confusing. Let's back up. First of all, can we construct things? Alright, cool. We can construct things at least. We're okay with that. A lot of problems there. Alright. So, we're looking at 1, and it's nil. And so peek just isn't working. Well, yeah, this couldn't work actually. So I got 2 failures. Okay, so for nil in Q1. Okay. So these last 2 are the ones that are failing. Let's just get down to 1. Alright. Next key is 1. That looks right to me. Min key is 0. That looks right to me. And okay, so at least that looks visually right to me. So what is it going to do? Well, oh, actually this has nothing. It just doesn't do anything. Yeah. But what about is empty? Alright, is empty. Next key is 1. Min key is 1. Values is 0, 1. Well, yes, that is true. Well, no, my remove should have removed that. It came in as, why is min key 1? Son of a bitch. It's really annoying. Because it's using it like it's a... Oh, he... No, wait. I mean, this is just stupid, but what if I... Oh my god, it's just off by one in some stupid tiny way that I can't figure out what it is. I feel really tired too. Let's persist. What do we know? Well, we know that the min key can't be. It can be equal to the max key. But it can't be the same as, or it can't be greater than the max key, right? I think this next key thing is just the wrong way to go. Okay. Okay. So although we did have issues with this, they're mostly in here, right? Just these two guys. Yeah, I think I'm gonna screw that up. Yeah, just these two guys. So let's just diagnose what's going on here. Q1, what does it look like? Well, that's a lie. That's what I hate about it. Is it's not even remotely true. Okay, so you got to make it true first of all, right? The max key is not 1. The max key is clearly supposed to be 0 at that point. So that means this is the only thing that makes sense, but that causes tons of other problems. Okay, so take this out, take this out. Let's see what we got. We still got 2 problems, man. The max key really screws stuff up. Okay, put in -1. That's great. I'm just putting the same code back that I had before at this point. Okay, and then so I mean that should fail, but it looks, at least it looks reasonable to me. That is, you've put one item on there. Your min key is 0 and your max key are both 0, right? Okay. Now, let's try enabling additional things. Let's ask about empty. If you remove a nut, you know what? Well, let's first just run it. No harm in running it. Okay, so we know something's weird there. But if we remove an item, it doesn't work. All right, so I don't know exactly what doesn't work, but let's just look at it through this mechanism. The min key became 1. It also did not remove the thing anyway. See this? The issue is there should be no max key or min key if you go to the empty values, you know? Or really, I guess it just be reset to 0 and -1 or something, right? You can't really go to the empty queue and have this make sense. I think it kind of starts off right, but it goes wrong the moment you go to the empty queue. So what do I want to do about that? The simpler thing to do would just be say, anytime you go to the empty queue, queue, just reset yourself back to the new queue state, basically. Okay, well, I mean, these two guys are the guys who actually changed the world. So let's just say there's a third function that's like reset Q on empty, right? It just takes a Q. And it basically asks the question if is empty Q, right? Then just reset the Q to, well, you know what, we're actually, this guy actually can technically be at the front. Kind of weird, but yeah, he can. Anyway, you can make a new Q, right? That's fine, and otherwise, just return Q. And so that means that it can basically pass this guy to this last guy. You're just going to do a basic sanity check. Oh, are you completely empty? Because if that happened, we might have put ourselves in an invalid state. And let's just reset ourselves. I keep doing that. Okay, so we got a nil. And it's completely freaking wrong. I don't get how it can be that wrong. Not nil. We called my remove on a Q, and it didn't remove anything. I mean, partially it didn't remove anything because the min key was just already screwed up. Why was the min key screwed up? I don't think this is the savior here. I think it's the fact it's the min. The min key is wrong. I mean, how is it getting to be wrong? It's like they are incrementing the min key, but they're not removing. They're not dissociating the min key. But how can they not be? Okay, I just want to see what the thing looked like right before being passed in, so I'll do 2. Alright, so the moment before, the Q is just all of this, right? And so this is presumably what we're passing to. Same Q1, right? To my remove, we're passing in Q1. We're passing this value in right here. But then somehow, even though my remove says update in values, disassociate min key, right, which has got to be 0 right now, right? And then update min key increment, which I agree, that's okay. Maybe does not make sense, you know, since the thing is now empty. But how is it that this is not working? This disassociate min key. How can that not be working? I'm just completely flummoxed by that. All right. What are you getting? You're getting a 0, 0, 0, 1. And somehow you're not actually removing the element at index position 0. Alright, so again, what is your min key? Nil. Min key. Key. Oh, son of a gun, I did it again here. I don't even get, why isn't this throwing an exception? This isn't even remotely valid code, and it's not throwing a compilation error. It's just accepting it. Okay, so at least we got that far. I do think that this is wrong, right? You cannot have a min key above a max key. That makes no sense. Which is why I think I am going to try this reset thing, right? I mean, I think this maybe only occurs when the values is empty, right? And so we should just be like, rather than handling all the different corner cases, whenever the values gets empty, it's just out of whack. And yeah, that seems fine-ish. Oops, there's my rice. Go cook my sausage. So that you should be back to being 0Q. Okay, cool. All right. Let's just try enabling other things randomly and see where we fail. Still okay. Okay. Surprisingly enough, still okay. Right line. Okay. So I don't think any of these has been corrected for the new guy, but let's just see what we got. We got problems. Nothing should crash. Assert failed. Oh, well actually that would be one thing that I would accept crashing. Okay, so you're saying this one crashed. My remove 321. My remove on 321 should pop. Should be 2-1, right? On a Q. Of course, this isn't even remotely the right data structure, even. So, let's just deal with the things that we actually know exist. Q from root. My remove on Q descending from root should be that's just too complicated. Yeah, let's look at the my peak, right, for that. On my remove Q is descending from root. So if I put in descending from root, that's too complicated. Let's do ascending. Yeah. If I put in descending from root, so it's 1, 2, 3, 4, 5, right, from the root, then the first guy out should be 1, right? I think we've already confirmed that actually on this up here. So that's fine, but what I did was I removed the first one. So the second one out should be 2. We're really not testing anything new. This has all been tested right here. Oh, crap. Okay, so I kind of feel like this is enough. So this effectively tests the peak functionality and the remove functionality for all 5 levels. Let me think about it. If you're ascending from the root, then if we put in 1, 2, 3, 4, 5, then you should get out peak-wise 1, 2, 3, 4, 5. If you're descending from the root, then you're going, you put in 5 first, then 4 second, and then 3 third, and then 2 first. All right, I think that makes sense. I really don't like the fact that we have to have this stupid reset Q on empty thing at the end. it just seems dumb. I don't get it. I feel like it's just an off by one somewhere that I just don't quite have the mental brains to handle. I mean, your is empty is in a invalid state mostly because you update you increment your min queue every time, even when just I don't quite get it. I don't get why they end up. I mean, I can see the flow, but oh well. I think it does work. All right. Anyway, so if we got cues, you know, I got lovely cues. So let's try to write some. Well, let's actually. I think there's some bugs. There's some errors here. So whoops. Let's get those out. Shaped out as well. Could not resolve symbol tick. All right. Line 60. So ped tick tick. Tick's pet. Oops. Somebody forgot to put birthday. Really? Oh well, they're on a test for it, so I guess that would not be surprising. So, oh, I have no idea how to test this. All right, it's like I kind of just want to write a little narrative where it's like one cat joined our shelter, one cat joined our shelter, one dog joined our shelter, one cat was adopted, kind of thing. It's a clever way to test this. Well, I need to take another break. All right, I think we got the. I think we may have gotten the cue. Okay. All right. Let's see if we can write the test for a second thing. I actually copied that twice, didn't I? So this is the shelter test. I guess. Not really. Just call this. No, what? Shelter test. All right. So how do we want to test this? Well, I guess we could just start with the most basic thing, which is I kind of just want to go through a narrative. So let's just start with something simple. I'll just test that shelter returns. I think tests like this are actually kind of stupid, but returns something that looks like Q cat dog. What does a Q look like? Q looks like a boink. No, just see if that passes. Yep, cool. All right. What else can we test? I want to test. You know what I kind of want to do conceptually is I just want to do operations, then assert them afterwards. You know, I guess I could actually do that with. Let me just experiment with that a bit. So let's just start with a shelter, right? And we have a shelter with no dogs and no cats. Did I start the video? Yeah, I did. Yeah, I really don't know about doing a chapter a day. I mean, it's, you know, I haven't worked all day, but, you know, I feel like I worked a solid amount of it, and it's just exhausting to do this stuff for. I mean, I woke up at 7:30 and it's 12 hours later. Okay, but yeah, I'd like to finish this chapter. Anyway, enough about that. Shelter. We start with the shelter, and we've already confirmed one thing, which is that the shelter is equal to this. You know, but then wouldn't it be cool if we could just do operations on shelters, like enqueue? I mean, we can do this, right? We can enqueue a on the shelter, right? A pet named, you know, kind cat, you know, whose name is Whiskers, right? And then once I've done that, I guess I don't think there's a good way to do this, but what if we tried doing this, right? This is the as thing, where basically everything gets bound, every s expression gets bound to the $sign, because that's what I defined it as here, right? And so the previous value, the shelter, is now the x expression, or the value here, bound, and I'm just going to see what happens if we, well, okay, so now here's where I'm stuck, I guess, yeah, so what I'd like is something like t slash is, you know, the result, what I enqueued. I mean, I guess I could technically just do this, and then that, and that binds it to the last. I mean, that means that this is a no-op, basically, you know. I mean, that's an interesting idea, at least. But, anyway, what do I want to check? What might I want to check? Let's just pretend it terminated right here, right? So if that's the case, and it terminated right here, what would I want to check right now? Well, I'd like to check that Whiskers is in the cat thinger, right? So I guess I might check that, well, one thing I might check is that this, what am I looking for? This tick is now equal to 1, right? Let's just see if that passes. Right? Can I resolve symbol as line 88? What is that about? Oh, whoops. Oh dear. Not an assertion. Uncaught exception, not an assertion. Juggling null pointer exceptions, ops increment. Well, I feel like that should have actually worked. Oh, I did it backwards. It just takes a shelter first and the pet you want to increment second. Well, damn. Alright, or maybe I guess that wasn't it, but. Oh, come on. Alright, so we got a shelter. We're passing in a new pet to enqueue to this shelter, so it should take a shelter and a pet. I feel like that's right so far. So I think we may not even gotten to this point. Let's see about that. Yeah, okay, so we know we actually have trouble with enqueue already. This occurred in increment, so the question is where. I feel like this is part of the problem with using the Bashka stuff. I feel like my stack traces have gotten a little less clear about what's going wrong. Maybe that's just me. So here's the update. But where am I calling it? Jeez. Where's my function? I don't even see any of my code in here. Yeah, it says line 84. Useless, yeah. Current tick is tick in shelter. Okay. Tick pet is associated pet. I don't think that could be what's failing. We're having trouble with increment, basically. Gosh darn it. And so it could be here. Update in shelter. We just want to make it kind of symmetric. We can do this. Shelter. Update on the kind of pet. Call my push on that kind of pet, which is a queue, and add in push the tick pet. Then just increment the ticker one. I don't see really how this could be failing, honestly. Let's just take that out to see if it still fails. No, it doesn't. So it actually means it's failing in here, which that sucks, because that's a harder place to find. Alright, oh, mostly because I thought we'd already tested this out enough that it worked. But I see the issue. This kind is... Well, I see a issue. Okay. So can we ask questions like, jeez, I'm just super tired. Is this tick equal to 1, right? So all we're asking is, did it increment the tick? Could not resolve percent. Yeah, you're right. I meant the $sign. Yes, it is. Okay. Well, so let's see if we can actually pull this out as a pattern, so I can actually use it. I'm just never used to reaching for macros because most of the time you don't need them. Is the main reason. But so let's stick with that bit of wisdom and say test and pass. That's a long name. I don't want to have to type that every time. What can I call something that... I just call it testo. I have no idea why, right? And it takes a function. And what it does is it says t/is, and it says call the function, and that's cool, but then what it also does is it returns, well, it takes a function, takes one of these thingers, right? I think that's a valid symbol too, actually. So let's say it takes a function, takes a value. That's a bit confusing. But I also call things print line pass all the time, so it kind of makes sense to me, but I can see that that would be a confusing name. No, that's just silly. Let's just do that. Okay. Takes a function, takes a value. Let's try that. Maybe that makes it a little bit clearer. And then returns the value, right? So it actually just threads the thing through. But so if we want to use that, we could call test as boom. And does it really matter? You know, actually, I do not know what happens there. Is this? I guess that makes sense, yeah. And so the return value of this should just be the same thing, right? No, so why am I saying is? I should just say is, right? Let's see if that'll actually even run. Cannot call test is with 0 arguments. Okay, so it's actually, yeah, it looks like it should take 1 at least, although yeah, there's no way for me to do this really. I guess there is a way, well, but then we don't need a macro, which is for the better, right? So we're going to take a value and a function, right? And the value is always just going to be, boom, right here, right? And the function is going to be an anonymous function that takes one of these guys, you know, so just test something. Right? So then we should be able to say test slash is, and we should be able to say function on the value, and then that should be an exception or not. Then we can say this as well. Whoops, I mean, we can say this as well. Right, that should do something. Could not resolve symbol test is, well, yeah, it's because we call it T. Okay. So maybe I want to test this, and maybe I also want to test this, that cats as a count that is now also equal to 1, right? Oh, good, it failed. All right. Well, not good, but at least I thought it didn't change. That worried me. Well, that sucks, because this looks like crap, honestly. You know? Yeah. So what if you didn't want to use a function? What if you wanted to try for a macro? Let's see what happens. Test is, because I want the thing to print out better. So with the macro, the nice thing is you can just use the body. But the disadvantage is I'm really not clear what I need, but okay. But then I also want to return what? you don't know. I mean, you want to return this thing, but you don't have access to it because somebody else expanded out your $sign. I mean, you could just do this if you want, you know. Then you can say things like, alright, it's kind of a stupid hack, but you could also find the $sign symbol in here and then just return that. All of these solutions, I feel, are less than great, honestly. But this one is, I mean, it's a bit goofy, but let's just see if we can just actually use it. So now you got tested as a macro. Let's just see if that even works. Could ourselves symbol user $sign. Yeah, I get that because you don't know who that is, and to be honest, neither do I. Okay, but what if I fail it? What does it look like? Well, that's actually not bad. Okay. Well, let's try it again. I mean, I wish I didn't have to put the $sign in there. That's kind of lame, but... do I have to put the $sign in there? I mean, what's the symbol going to be if I don't? Nobody knows, right? Actually, we're also not clear that it's actually passing it forward correctly, so let's try that too. But test is this 2, and also test that 1 is equal to the count of, is equal to the $sign cats count. Is 1 equal to 3? No, it is not. Oh, but it's actually not cats, it's actually values under cats. Cool. Now, I've entered a tiny little thing. It's kind of awful, honestly, but the cool thing is now I can just keep doing stuff with the existing thing I have rather than having to just like create a separate test case for every single one. You know, although this might actually, when I think about it, be better to declare it as like a sequence of, like a vector of things I want to do and then test I want to run. And it could just sort of figure out, I mean, if the S expression starts with a T, then it's probably a thing that I want to run under testing or something. Whatever. This is okay-ish. Alright, so we got cats. Alright, let's try to pop it. So we DQ cats. Okay. Does that mean we go back? Not quite back, but test is you know, all these DQs should, well, they'll all throw exceptions if you try to DQ from something that is empty, so I guess that's fine already. Let's not test that. I'm just going to assume that works. I'm really tired, as you can tell. But let's test that. You know, the cat is back to 0, right? I guess we can also, hell, we can just test both of them, right? Kind of a dumb test, but tick should still be 1, right? And cat should be back to 0. That didn't work. Oops. Assert failed. Not is empty queue. Ah. Wait a minute, I thought we successfully did this. Why, how is any of this failing? This, I'm not even calling a function. Oh, I screwed up. Okay. So this is okay. But if we then try to dequeue... Ah, I see. You can't peek. It's something that's empty. Lame. Oh, man. Okay, you can't peek at the empty thing, so rather than actually peeking at it, do we want to just... Oh, man. Okay, I guess we could just try catch wrap that whole thing. And if you're... Well, no, because I want them to fail if both of them are empty, but if one of them's not empty and the other one is, that's okay, actually. Um, One of them's not empty, the other one is, that's fine. What are we going to do about that? I guess that's why we have the is empty thing, right? So we can call shelter cats is empty, and then if it says empty, we can call the mic peak. Yeah, that's too bad. This thing was pretty tight before. Now it's got to handle the fact that one of them may be empty. Lame. So tick cat, tick dog. If and tick cat. No, what the hell am I doing? I can't think of a good way to do this other than just going through all permutations. Why is DQ so busted? Well, let's do a cond. Whoops. And if it is the case that shelter cats is empty. Wait a minute, have I said is empty twice? No. Okay, yeah. Shelter cats is empty. And shelter dogs is empty. Alright, if both of those are true, then we kind of just want to raise this assertion. I kind of want to raise the same assertion that everyone else raises, right? Then maybe let's just... Can't base it on tick, because you could have popped things off, but we can base it on... I mean, this is what we're asking, basically. But one of these not be empty, right? So if both of them are empty, then both of them will be false. Then the not will make them both true. Sorry. If both of them are empty, this part will return true. If cats is empty, this will be true. And we want it to be false, so we actually want to negate it. Okay? And if both the cat is empty, set to is empty is false, and the dogs is empty is false, then the assertion is false, and we can just stop dealing with this. But now I can go back to if, yeah, just this right here. But, so now we don't have to worry about both of them being true, but it is the case that one of them might be true. So what we can then do is just put in a -1 at the end. Right, so one of these will be true. You know what, that won't work, because it's going to explode right here. So what I'm going to do for you, I'm going to do this for you. I'm going to say hoop, 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 hoop. Good Lord. All right. Well, it did fail at the beginning. Actually, wait a minute. It still feels wrong, isn't it? No, it should be... if either cats is not empty or dogs is not empty, or both are not empty, that's fine. Fuck it, this is too complicated. Okay, if tick cat is equal to tick dog is equal to -1, then we're in real trouble. And okay. On the other hand, if tick cat is less than tick dog, then we're going to do this. What? Otherwise, we're going to... tick dog must be... So we have a slight preference for cats. Because we do the equality. Well, no ticks will be the same, so it doesn't matter. There is no slight preference. Could not resolve symbol raise. Where's raise? Oh. Why? Why are you being so difficult? Assert failed. Not is empty Q. What? Yeah, okay, you raised an assertion, and I tried to catch it. Well, what's your problem? Oh wait, it's lower. That means whoever's lower gets it. Yeah, we don't want the lowest one. We want actually the biggest number we can get. So let's say... So we want to throw a huge number out here. You know what, I'm just gonna... This is one place where I might say that you actually want to do... greater, right? Okay. If the cat is younger than the dog, then DQ the dog. Otherwise, DQ the cat. Oh, come on. I shouldn't be going to this. Okay. Everything's just in the interpreter. Well, it's gonna just say 76, which is right. Actually, it's not. Line 76, column 3. It's trying to run this one. Well, at least it may be. It's no way to know because... Okay, so that's actually not the issue. Despite the fact that it says this is the line that the error occurred on. But about this being the issue, that is the issue. Which makes sense. It's saying, tick dog, we tried, and we failed to catch. Is that because this isn't an error? Maybe it's... I don't know what the... I think I've looked this up once. An exception is something you can handle on a... Java.lang.assertion error, okay. Is error not the superclass of all assertion errors? Yes. Come on, I'm trying to catch this thing. What the hell? Try and catch it. Java.lang.assertion error. Okay, what the heck? Tic-tac. These are both -1, then do that. Why can't I catch this? You don't really think you need anything. You're clearly catching it from within here, but you refuse to actually catch. Catch exception E. I'm lost. I don't understand what the issue is here. Huh. Maybe that's not where it's failing. Maybe it's failing further down. Like, for instance, somewhere else. I don't know. How would I know since I can't read through any stack trace here? Line 23. I guess I could take that hint. Line 98. Okay, so line 98 here becomes line 23 here. It's being called by update. No. Okay, I'm on the wrong one. This one. DQ dogs, okay. And one of these guys is calling update. I've seen that. Just sanity check if this. No, it doesn't fail at all. Okay. It's definitely in here. We're going into here. We're having an issue with DQ, but it is going into one of these, specifically cat. And then from there, it's pretty basic code, but pretty much has to be failing in my push, right? No, it's actually feeling in my remove. Why is it calling into my remove at this point? Oh, because we're DQ'd, and that's... Wait, we DQ'd. DQ calls into this.
Oh. It doesn't call into NQ, it goes into DQ. I'm just being dumb. It calls into my remove. Wait, what? Okay. Calls into my remove. Okay, somebody's failing on line 23. You know what? Maybe I can get a better idea about what's going wrong if I do this. There's way too much being printed up. I gotta call it out again. So we can just remove this one entirely. And okay, my remove. Max key is -1. That doesn't make sense. Oh no, I guess it does because wait, it already looks like it's been removed. I mean, this is the reset value, right? So this shouldn't be what we have. This is either the initial value or the reset value, right? So this doesn't look like the right one. Could it be that it's the one with the lower tick is the younger of the two? Cats, yeah. But that sure looks like you're trying to remove something. Alright, I gotta stop. I'm clearly fading, but so print line, DQ, shelter. Print line. We're pretty sure it goes through the cat's flow, but let's just make sure. Print line. Well, DQ cats, shelter. Print line, DQ breed, shelter and species. Alright. DQ breed. Did not go through DQ cats though. Does that mean we went through DQ dogs? We did. Well, let's reverse what I did. I feel like that's a bit of a problem. If the cat is less than the dog, then I think it's younger. Let's run the cat. Otherwise, let's run the dog. But we do have this issue with -1. The cat will be younger than the dog. See, the problem is now I need sort of the opposite. I need the biggest number you can get. Yeah, so just figure out how to make the logic right, but it's not right. If the dog is bigger than the cat, and the cat is younger than the dog. Okay. So first of all, let's just make sure we're going through the right one. We're still going through DOS. God damn it. I feel like the logic there is just backwards, but evidently I'm wrong. Okay. Okay, they can't all go through the dog. Unless... Nope, I didn't misspell it. Unless this is just never true. But assuming they're both returning numbers, they have to be... One of them has to be true. Alright, well, let's confirm that. Okay, so tick dog is less than tick cat. Well, yeah. So you can't be using the less than thing. You need to use whoever's bigger needs to run. Well, actually, no. Whoever's smaller actually needs to run. Actually, you know what? Let's just... Rather than trying to do this at all. Okay, well, no. I want the rat values. Oh, no, maybe I don't. I just want them to be... If they're both nil, then we got a problem. If tick dog is nil, then if tick cat is nil, then you gotta do the dogs. If tick dog is nil, you gotta do the cats. Right? We know they're not both nil, so if one is nil, the other is nil. We've handled that. Now, what if neither of them are nil? Then... Okay, yeah. Then do the cat if the cat is less than the dog. Otherwise, just do the dog. So we have a preference for dogs, which I think is entirely reasonable. Holy crap, okay. Alright. I'm gonna leave the print lines in there because I just feel like there's gonna be more issues. But test is. That should never happen. Well, a similar friend we will have is printline pass. O. Print lines O, and then passes. O back. Let's see what the. Well, I guess we don't even need that actually. Let's do this. Or you just do this. Okay, so is nil equal to a shelter with tick 1 with no cats in it, no dogs in it, and oh, I forgot, we're returning pet. We're doing this thing, yeah. I forgot. Okay. Okay, so it's not really that there's an issue, it's just that we need to we need to pull the shelter out of the whole thing. I have to remodify something with deck DQ. Maybe we can pass these as well. Okay, cool. Alright, oh, I'm getting so tired. Alright, let's try putting a dog and a cat in there. Alright, let's just try putting a lot of stuff in there. Okay, so I'm gonna put Whiskers 2, Whiskers 3. There's 2 cats in there we put in first, right? Then we put in 1 dog. His name's Fido 1. Let's call this guy Whiskers 1. Fido 1. So currently we have 2 cats that are older than the 1 dog, right? And so if we ask to pull all of them, we should pull the dog, or the Whiskers 2 out. Right? So, alright, and oops, something funny here. Well, we can sort of check the result of cats even. Bit weird, but we can sort of check the result of cats by taking the pet, and asking if it is equal to. Well, let's just ask the last thing. These are kind of like cyborg animals. It sounds like Whiskers 1, Whiskers 2. Alright, but the pet name should be equal to Whiskers 2, right? And it'd be nice if you were a little smarter than that and you could print out what it was a little bit better than that. So you're saying it's nil. I disagree. But let's back up 1. Maybe you're right. You're saying That is the value of NQ. That does not seem to be the value of the DQ. I think the DQ should return both. It should have two keys in it, right? Yeah, the DQ should have two keys. It should have the shelter, and it should also have the. Oh, there's the pet right there. I pulled the pet out. That's not really the pet that you're obviously popping out. The pet is. Pretty sure that's the. Well, I'm just gonna get the whole thing now. Okay. So we were looking for Whiskers too, but we didn't get it. But what we did get is an entire map containing a shelter, including this whole thing. And a pet. Wait, no, this whole thing. Yeah, I don't think pet is right. I think pet is. So this is you peeking at the pet. That doesn't seem right, does it? The peek should return the thing that you would throw off if you. The thing that you'll drop if you ask to drop, right? But that's not this. The pet should contain. It looks like my peak is kind of. It kind of looks like my peak is returning. Well, two things actually. Cats. It just contains a. Okay, yeah, here it is. Have we confirmed the peak works correctly? That doesn't feel right, does it? In the shelter for this species, my peak has conventionally returned the value out of. Returns a simple value, but it doesn't seem to be holding a value. Okay, let's. Let's back up here. One tick. Cat's values count. So rather than doing this at all, what we're going to instead say is cat's values count. That's fine. But then what we're also going to say is, hey, okay, let's just actually, now that we know there's only one value in there, first is equal to. Actually, no, I don't care about any of this. I just want to do cats, and then I want to do my peak, and that should be equal to. And then from that, I also want to take the name out of that. And that should be equal to whiskers 2. Whiskers 1, I mean, at this point. You're saying... Okay, yeah, I get it. Okay, we're still good. So up to this point, the cat looks right. Then we're going to DQ it. So we were able to peek correctly on this cat. We're still okay up to this point. Okay. But then when I try to do this, presumably we can still succeed, right? Okay. That made no change. So then I'm going to do the same thing, but I'm now checking that we were able to enqueue whiskers 3. But no, it's still looking for whiskers 2 on peak. Whiskers 3. So we just enqueued another cat, which pretty much means our peak is not working correctly. My peak on cats, which is a queue, should be saying, oh, it is. It's a fucking queue. I just keep getting confused about that and keep thinking I should see the latest thing I've pushed. Now, your peak is still whiskers 2. Doesn't matter. Okay, I'm just obviously. In queue. Okay. Just sanity check. Just help me out, people. But we're still whiskers 2, right? Yes. Okay. Now, if we DQ this guy, and then we check, what should be in there? Well, no, if we DQ and then we do this thing where we just kind of... Let's just ignore that, right? And we check. Let's only check through the interfaces rather than trying to check things directly. This is like problematic. We do this, and then we peek again. It should be the same thing, except now the peak should be for the cats at least, should be whisker 1, right? Yeah, fuck. Or maybe I meant whisker 3. Okay. But if we... You know what? I'm going to try putting the dog in before the cat. Whiskers 3. No, you know, I'm just going to undo everything I've done. So, alright, Whiskers 3 is still the thing we're going to peek. Now I'm going to DQ a cat. DQ cats. And it's not incredible, but okay, I got a shelter. And now okay. The final thing is if I peek, if I plop a dog again. Alright, so if I DQ the last time, if I DQ again, then I, rather than shelter this time, I'm going to test is on the result, but I'm going to do on the pet. I'm just going to say is equal to nil. Because I'm not sure what the hell is going to. Should just be the cat, but it's clearly not. That's definitely not the cat. Or the dog, I mean to say. It should just be this. Instead, I'm just not even clear where this would come from. I mean, this is clearly a whole shelter, not a peak. Why isn't it returned? And it's weirder than that, because it's not even a shelter. Well, no, it's the cats. The cats. The cats is the queue, right? But the dogs is just the dog that was returned. How the fuck does that happen? All right. So I think the good news is it's just something that's wrong with this pet thing. We're gonna update in shelter. Okay, so maybe that's the issue. First of all, why am I updating in shelter? I should be within shelter species, right? Or it's fine to update in shelter. It doesn't really make sense, but then you should just get. No, I should just be getting shelter species, right? So I should be going shelter, get species, and then I'm basically saying my peak on that species. Well, okay, right. I feel pretty good about that because then we're gonna say Fido1 is what the name I expect to see. Good. Good. Holy moly, that took a lot of work. All right, let's just. I mean, it's kind of dumb, but let's actually just chest these out too. Okay. Whoops. Well, they're not going to pass with that thing, but this guy should be the pet that we dropped at this point. Should be Whiskers 2 as well. Right? At this point, the pet we dropped should be Whiskers 3. Whiskers 3. And at this point, the pet we dropped should be Fido1. might as well run the other one, which is just that. Actually, I don't care about this. This is looking at the internals, and this is not something we should be doing anyway. So this, I guess, is okay, right? Just to check that the whole thing is empty, because we have no good way to do that, you know? So after we drop both of the cats, right, like one thing we should be able to do is say, hey, yeah, the number of cats is empty. And after we drop all the dogs, right, we should be able to say, oh, yeah, the number of dogs is empty. And after we drop all of that, how many things have we enqueued? Well, we enqueued 1, 2, 3. We enqueued 3 cats and 1 dog, right? Which means our total count should probably be... no, I'm not going to even mess with that. I don't care. Yeah, but I do. I lied. I think our count should be 4, maybe? Alright. Who failed? Let's just take off these last 2 and see what happens. Let's take off, okay, some more. Or who's failing, actually? Line 106. Oh, useless. Whiskers 2 is equal to the pet's name. This is when we're still holding a shelter. I just really don't know about that. But Whiskers 2 is the pet's name. I think I just really like the I don't think the DQ is a good idea. It just makes this just really painful, you know? But we are still holding a shelter at this moment. And so we should be able to look at Whiskers 2. No, this is in the wrong place. After we DQ, we now have the whole thing that has the shelter and the pet. And so at this point, we should be able to get the pet's name. Yeah. So that's what we just popped off. And then we say, okay, forget it. I'm done. I'm happy with the shelter. And, alright, I want to convert. I just want to use the shelter. I'm done with talking about the pet. And so we say shelter 2. And then we DQ an actual cat. And when we look in the actual pet name on the actual cat, it was Whiskers 3. And we're also just confirmed that, yep, now the cats are empty. Actually, we can just do this first and avoid one. So now we don't have to say, yeah, okay, yeah, I think that was actually what I meant. Go to grab the cats, look at the values, check the count is 0. Cool. Which actually, yeah, the correct way to do this is to say the cats is empty. That's a little bit better. And then we DQ again. Now we're back to having a shelter pet thing. And I'm going to check that the pet is Fido. We're going to check that if we're done with the pet, let's just go check the shelter. So let's convert it into a shelter again. Now we can stop doing this shelter thing. we can say shelter dogs is empty, right? That should be empty as well now. And the final thing we can say is, that's obviously not going to work, but we can say that the tick is equal to 1. And by 1, I mean 4, I think. So we got 1 failure. Is empty. Okay. Did I just type that correctly? Yes, I did. Okay, that's enough of that. Okay. Animal shelter. Oh. A little of both. Yeah. Yeah. I guess I'm not really, but yeah, a little of both. Really. I am planning on doing some interviews next month. And I am playing. My algorithms is weakish. Oops. Okay, yeah. Sorry, I guess that's annoying that you can't even see what I typed. Okay. Cool. So, Animal Shelter, problem 2.6 of cracking the code interview 6th edition. Okay. Well, so, I mean, this one was kind of interesting in that I did implement my own queue, right, using a map, a min, and a max, a min key and a max key. I then went ahead and implemented the algorithm thing, the actual shelter thing, as a second bit of code, right? And I wrote some tests for them. And also, I guess the other interesting thing which we did was this kind of pattern of just being able to write a long-winded thread, you know. And, you know, I don't know if it's a good idea, but it's fun to try new things every once in a while and see if that's anything interesting. I was happy that we were ultimately able to write a queue using just, I mean, in my head, it totally seemed like we should be able to write a queue with just a map and a min count, right? I think I can see why you need a max count too, and you can't just use the count of the size of the container map, you know. I think actually. I don't honestly, but I ended up using the min queue and the max queue, right? And that does introduce some difficulties because at some point I get the min queue out of whack with the max queue, and I don't quite see why that is, but I'm way too tired to try to figure that out at this point. And so, yeah. Yeah, I think it would be cool to look back on this and see if there is a way to just write a queue, in an immutable queue enclosure with just a map and a min count, right? And not a max count. Because I think if you could do that, you can also write a queue
that doesn't need that goofy reset behavior right here, right when you get to the empty queue, which I consider somewhat of a code. Well, it's not a code smell, but it's just something's wrong. I feel there. But anyway, then, yeah, the logic once you have a queue, which as we saw in this code over here, you would never do this in reality, right? You don't need to write your own queue. There is a queue. There's a way to you can just use this thing, right? Yeah, so don't write your own queue, basically, is the take-home message. Not that I think that really ended up being the problem. What are the most difficult things about this one? Well, I guess it was probably taking on two things, writing a queue and using the queue. But two, this feels a bit weak. It just feels like there's something elegant to do here, in terms of figuring out what's wrong. I think the biggest thing is the whole idea of DQ is really not in line with functional data structures, right? Immutable data structures, I mean to say, right? Because it's like you're returning a thing and as a side effect, mutably changing the object the thing returned from, right? It's like this is pure, right? So it's or immutable, so it's not it's not like you've had things hidden from you, but I think it would be better just to not use a DQ and instead just have two separate functions. One function would be, since it's basically since the adoption agency is basically sort of a weird queue, right? Just I guess call one of them add and one of them drop, and then call it drop cats and drop dogs, or and just split it up, right? Split up the dropping from the peaking. Yeah. So anyway, whew, I need to do something relaxing like Stardew Valley or something like that. I'm burned out at this point. All right. Yeah. So we got this 3.6 great review, and that's all I have to say about that.